Alright, so today in class we're going to look at two different things. We're going to look at some symbols, and then we're going to talk about algebra proofs. So we'll get to that in a few. Let's look at symbols first. The first thing we have is we have P, Q, and R. P, Q, and R are letters that represent verbal parts of logical statements. So we take out all the words and we just put a letter in. And we kind of talked about that previously when we looked at conditionals and things like that. We had P's and R's, and then we're going to introduce Q also. So then it says this implies a conditional statement. Okay, or indicates a conditional statement, and that is very simply just an arrow. Okay, an arrow implies or indicates a conditional statement. Biconditional, if and only if, is an arrow going in both directions. Not, something that negates the statement, that's the little squiggly. Therefore, this is 3 dots. That indicates therefore. Okay. Intersection of two statements, this is new. This is an upside down U. And the union of two statements is just a capital U. Okay, so make sure you get those down. So let's try some practice. So if it rains on Friday, then the football game is postponed. Well, P is it rains on Friday. Q is the football game is postponed. When we have if and then, that means it's a conditional statement, and this goes in that same order. So it rains on Friday, the football game is postponed. This can be simply written as symbols with P, arrow, Q. Okay? Let's do one more, and then you're going to try something. The football game is postponed if and only if it rains on Friday. So this time they put the Q first. The football game is postponed. So let's do Q, because the order matters in almost everything we do in geometry. An arrow going in both directions, and then a P. All right. Go ahead and pause the video here. See if you can do the other three yourself, and then unpause the video and check your answers against mine. Okay. Pause the video now. So hopefully you got 3. 4 and 5 might have given you some trouble. If we go back a page, we have the intersection of two statements is this, and the union of two statements is that, and it's and or, but we can also write these like this. And as a capital V, it's like a capital A just without the line across, and or is a capital V. All right, so let's go back. That's probably easier now. Sorry about that. So we have it does not rain on Friday, so not P, and the football game is not postponed, so not Q. And then the football game is postponed, so Q, or it does not rain on Friday, so or not P. Okay? All right. Let's take a look at the next page. Just some more, okay? So just some more. Go ahead and pause the video again. Try and do these on your own, and then unpause and check your answer. Okay, so check your answers against what I have. You have to be very careful anytime you see the not, right? The not is not in either of the originals, so when I see a not, I know that I'm going to have the negate symbol. That's usually where a lot of students mess up. And then the difference between and or, just the easiest way to remember that is and starts with A, and that looks like a capital letter A, just without the horizontal line. All right, if you have any questions there, make sure we go over those in class to clear those up for you. So here we're going to translate. We're going to go in the opposite direction. So I'll do one, and then you guys can try the rest. So Q, this is Q, so I can just go right to Q. Q is cows make milk. So I can write, and I see this arrow here, so I know it's going to be an if-then statement. So if cows make milk, then, and it has the not sign right there, so then I would write the moon, then the moon is not blue. Now, does that make any sense? No, but it is correct. So that's what we're worried about. All right. Go ahead and pause the video here. Try and get the other 3 on your own, and then check them. Okay, so here are my answers. Here's what I got. I got if cows make milk, then the moon is not blue. We did that one together. The moon is blue if and only if cows do not make milk. The moon is blue or cows make milk, and the moon is not blue and cows make milk. If you have questions on any of those, you're dismissed. If you have questions on any of those, be sure to ask me in class when we go over the practice, okay? Okay, so the next part of the notes is on algebraic proofs. So we have to go over some, stop looking at me. We have to go over some properties, things that you know from the past, so we'll look at those now. So the addition property, basically the addition property of equality says you can add the same number to both sides of an equation. There's an intruder. Pause the video. The subtraction property says the same exact thing except for obviously subtraction. So same thing, but we can subtract the same number from both sides of an equation. Multiplication property, again, same thing, but we can multiply. We're going to come up with the examples for these in just a second. Division property, same thing again, but divide. And then the substitution property, that is, you can exchange a part of an expression with an equivalent value. So let's get some examples of these. All right, so if we go up here to the addition property, very simply, when we have an equation, if we have, x equals 2, if x equals 2, then x plus 2 equals 4. We just added 2 to both sides. Here, if we said y equals 8, then y minus 3 equals 5. We subtracted 3 from both sides. Here, if z equals 2, then 5z equals 10. We multiply both sides by 5. Here, if 6m equals 12, then m equals 2. And here, if we have, let's see, if we have, get this out of the way. If we have 3x plus 5 equals 3, and x equals 2, then we can substitute that in. So 3 times 2 plus 5 equals 3, which of course is not true, but that's just an example of substitution. All right. Exercises. So support each conclusion with a reason. Go ahead and pause the video here and try these two, and then see what you get. Pause the video now. Okay, you've unpaused this one. Hopefully you got, this is subtraction. Let's make that a little bigger. Okay, and then hopefully down here for this one, and then down here we have the measure of 1 plus the measure of 2 equals 90, and here we have the measure of 1 equals 90 minus that, so that is also the subtraction property. We subtracted something from both sides. Okay. Next page. Go ahead and pause the video again, try these on your own, and then unpause the video and we'll get some answers. So pause the video now. Okay, so for these, hopefully you got the addition property and the multiplication property. All right. Any of these that you're getting wrong, you want to put the highlight somehow, and then we'll go over them together. Pause the video and go ahead and try these. All right. Hopefully for 5 and 6, you got substitution and addition. Let's take a look at some more. So here, this is more like what a proof looks like. So we're going to actually fill in the columns where the reasons are with statements. So we give you a statement, and you have to prove why. So the easiest one is usually the first one. That information is given. And then how can we go from here to here? What allows us to do that? Well, what happened? Really, it's just about what happened. And what happened was we subtracted from both sides. On the next step to get from here to here, we're dividing both sides. So it's just a division property. Okay? Division, dividing, either one is good. Let's go ahead and take a look at the next page. So here we have a lot more examples of properties. These sometimes are more relevant for geometry problems, but will work for algebra problems also. So the reflexive property of equality. So it's just a little easier. I filled these in for you. Go ahead and get these down. These are the words, and then, so while you're getting the words down, I'm going to put just an example down of each. So for example, AB equals AB. Angle Z is congruent to angle Z for property of congruence. XY equals ZA. So ZA equals XY. That's just switching the order. If angle Q is congruent to angle R, then angle R is congruent to angle Q. The transitive property would be, for example, if KL equals MN and MN equals TR, then KL equals TR. And then same thing with congruent. So angle 1 is congruent to angle 2. Angle 2 is congruent to angle 3. So angle 1 is congruent to angle 3. The distributive property, this we know. This is old algebra 1 stuff. So like 3 times x plus 4 is the same as 3x plus 12, right? The step that we didn't write was 3 times x plus 3 times 4. We distribute that. The commutative property, this is where we say 2 plus 3 is the same as 3 plus 2, okay? Because they both equal 5, so we can change the order. And the associative property is when we do stuff like this, 2 plus 3 plus 4. And if we add 2 plus 3 first, that's the same as 2 plus 3 plus 4, okay? So change the grouping. Alright, so that's that. Let's take a look at the next page, just some matching here. We need to match the property to the appropriate statement. Go ahead and pause the video here, get some answers, and then unpause it and check them. So here are the answers that I got. I just drew lines. If you drew letters, check to make sure you have the same things matching up with the same things there on those questions, alright? Alright, so now we actually have a proof, so let's go through this and try and fill this out. So the first one again, the given information is usually in the first statement, not always, but usually, so that's easy. That's a reason that we should always get right. Please never leave the first blank on a proof problem empty when you could probably write given and get it right most of the time. So the next thing is, what's different from A to B? Well, look at it. We multiplied both sides by 2, so you could just write multiplication, okay? Multiplication property of equality, so that's perfect. Then here on the next line, we have this simplified to this and this simplified to that, but simplified is not a reason anymore. What you have to write is substitution. We took 2 plus 7 out and wrote 14. We took 3x plus 5 over 2 times 2 out and wrote 3x plus 5, so that's substitution. The next thing we did was subtraction, because we subtracted 5 from both sides, and the next thing we did was division, okay? Yikes. Alright, so there's that one. Alright? Go ahead and pause the video here, try this one on your own, and then check it in a minute. Try them all. Alright, so first we have given. Hopefully after that you got multiplication. That sometimes is a hard one, but we multiplied both sides by -2. After that, to go, the only difference here is from this to this, and that's the distributive property. Okay, after that, we subtracted from both sides. We subtracted x from both sides and 2 from both sides, so we did it in one step. Here it's division. And here, that is symmetric. Alright, that's it for the notes. Good job. Thanks for being so quiet in the background. Big thanks to Lauren. She was the best.